is a typical example. Again, this is zoom in picture of a linear approximation. Not good enough, right? This looks like good enough in here. Soon it takes off. So here is quadratic picture. This orange is a quadratic function. This blue one is actual function. So we have a whole lot better region. The function and this quadratic function overlap pretty good. So we want to go into next level. Okay, it's a quadratic approximation. So I want you to add to your note this new formula. I want you to compare that with a linear approximation. Notice that first two terms, this and that, is exactly the same as linear approximation. So all you have to memorize is just one more term is added on there. It has x minus c just like a tangent line, but it has to be raised to the second power to make it into a quadratic function. And the coefficient here, f double prime of c divided by 2, is another thing you have to remember. Analogous part is f prime of c is involved in the next part, f double prime of c. Okay, I can think about that. But why is there 2? That's not easy to understand at this point. But it'll be explained itself eventually. Okay? So f of c, f prime of c x minus c, tangent line formula, linear approximation still there. Add one more quadratic term, x minus c squared, and pay close attention to this shape of a coefficient. Do not forget the 2 in the denominator, right? Again, this c has to be at such a value such that f of c, f prime of c, f double prime of c can be easily computed even by hand. Okay? Make sense? So, right, here's an exercise. Remember I asked this question last time? How do they make the table of sine x? So if you punch it into a calculator, it just tells you what the value is down to 10 decimal places, right? How do they get that value? They actually use this idea, right? So I chose this value. Do you know what that value is at x coordinate there? What's that? Yeah, no. What is the x coordinate of this red dot there? 0 0.8. Which one? More precise? Pi over 4. Pi over 4 was the answer, right? Why is it pi over 4? This is linear and quadratic approximation. Add pi over 4, and that's the point. Pi over 4. And the blue one is actual sine x. This orange one is a quadratic. Good? Okay. So here's what you're going to do. Remember this f of c, f prime of c, f double prime of c is involved in there? So we're going to prepare that first before you go. So what is our c? Pi over 4 is usually given, but we talked about the principle as well. Pi over 4 in degree, how many degrees is if it is pi for radian? 45 degree. 45 degree, we can calculate sine, right? 45 degree, we can calculate cosine and so on. That's why I chose this 45, right? And there's a 30 degree, 60 you can do as well. So what is next thing we have to compute? F of c, right? Which is the sine of pi over 4, 45 degree. Who remembers sine of 45 degree? 1 divided by root 2, right? This whole thing is about approximation business, right? Keeping a square root 2 has no meaning, right? You can just change that to approximate value. So can you give that to me? Can you go ahead and calculate the value of 1 over square root 2 using your calculator down to 4 decimal places, please? It's a 0 point. If it is degree, it has to be sine of 45, but this whole problem is going to be all radian, so better change it to radian and type pi over 4. It's not degree. Once you're out of the sign, there's no degree radian. That is just a number. Usually it's the length, meters, inches. Somebody did 1 over square root 2? Thank you. That sounds about right. Well, I got that one. So what is the next thing I have to do? Think about, in your head, think about quadratic approximation, right? What is the next thing you need? f prime of c, right? So who remember f prime of c? Cosine of what? C, right? Now you replace the cosine of pi over 4. So tell me, what is cosine of pi over 4 in exact value? 1 over root 2, that is the same value. And it turns out 0.7071, right? In general, they're not the same. Sine and cosine are not the same because 45 is right in the middle in between 0 and 90 degrees, and that's why it's the same. All right. Who remembers next value? F double prime of c, right? We need to calculate that. What is f double prime of c? Minus sign. We differentiate f prime of c one more time. So negative sine of c, right? So negative sine of pi over 4, which you already calculated, right? So here's a negative 0.7071. Okay? So relative to sine of something, 1 over square root 2 is easier thing to calculate. Suppose you use the bisection method to solve equation x squared minus 2, so you prepared 0.70. Yes, that is the same value. Square root 2 over 2 is the same decimal, 0.7071. Yeah. Anything else? So do we have everything ready? Yes? What is a pi over 4 in decimal? Can you do that pi over 4? That is 1 point, no, it's a 0.754. All right. Do you think you have everything ready that involves C, right? In the quadratic quadratic approximation. So I'm going to write qx. I'm not going to write f of x. It's a qx, a different function. It looks a lot like it. So qx is exactly equal to. So what is the very first term? Does anyone know what the very first term is? What's that? F of c, what is it in decimal? Right, 0.7071. All right, what is the next one? F prime of c, right? What is it? 0.7071, isn't that right? Now, what is the next one? X times x minus c, right? What is c? Yeah, 0.7854. So it's 0.7854. Everything good? All right, what is the last term? Right, it's a negative, right? And there's x minus 0.7854 squared, right? Do you know what is multiplied to that? X minus 0.7854 squared? Over 2, right? Over 2. So can you divide that for me? This is 0.5, 3532. Is that right? 3522, right? Yeah. Okay, that's it. That's the quadratic approximation. See what happened to negative 0.7071. You divide it by 2, 3532. Any question about all these 1, 2, 3, 4 numbers you got? Good? Yes. Okay, I think so. 6. That's right. Thank you. Anything else? It's good. All right. This is not exactly sine x, is it? Is this sine x? This is not equal. Look at the graph. They look alike here, but not exactly overall, right? So what is the symbol that connects these qx and sine x? It's wiggly equal symbol. Sine x value is going to be very close to that. Very good. That's the answer. If I ask a quadratic approximation, this is what you do. What about linear approximation? Lx is a piece of cake. Everything is ready. What is a linear approximation? You just copy the first two things here, right? That's it. So it's a 0.7071, 7071, x minus 0.7854. That's the linear approximation. Question? It's not an exercise, it's an example. Yeah. Yeah. I said exercise. It's all recorded, so I can't deny it. So I apologize. This was an example. Okay, so why do we calculate this QX? Why did we calculate this? I asked you to calculate it, but what is the, you know, reason behind considering all this? We want to use QX formula instead of sin x. Instead of sin x is approximately equal to that. Good? So if you have to calculate what is pi over 4 in degree, that's 45 degree, right? So if you believe 40 degrees is close to 45 degree, then rather than plug in a sine of 40 degree here, we're going to plug in 40 degrees there in radian. Okay? So I want you to go ahead and change the 40 degrees in radian. What is 40 degrees in radian? Approximately. Down to 4 decimal places. The formula is this, right? 40 times what? Pi divided by 180, right? That's how you change the degree measure to radian by multiplying this factor. So what is it in decimal? Can somebody tell me? 6981.6981. Agree? Okay, so that's that's kind of close to our pi over 4, which is a 0.7854. That's our C value, right? We're about to plug in X value what? 0.6981. So that will be the approximate value of sine of what degree? 40 degrees. It's an amazing moment of your life. You're about to calculate sine 40 degrees with these thoughts, not using a calculator. If I pay you, you can multiply all that, right? Because all you have to do is multiply decimals and add and subtract, right? Yeah, we can do that. So let's do it here. Let me write down the whole summary. Sine of 40 degrees, right? What is in radian, roughly? Because we took this approximation, I go like this. Sine of how many radians? 0.6981. Is that right? But sine of this thing, which is very close to C, which is 0.7854, can be replaced by Q of, right? 0.6981. Do not try to learn the pattern. See how what I write and what I go by, the formula. You write this one down, you use this formula correctly and things like that. All right. So if your input is a 0.6981, all you have to do, you plug in your x, this is your x, right? Into that formula. How many x's do you see in the QX? How many x's? There are two x's, right? Those places there should be replaced by 0.6981. Okay? So I'm doing that, writing it down, and this part's easy. 0.7071 plus 0.7071. X is replaced, 6981, right? Minus 7854. Make sense? And minus 0.3536 times 0.6981 minus 0.7854, then what? Raise the square. Now imagine you're doing this one by hand, right? Multiplying is so boring, but it's something we can do by hand, right? If you have time. Yes, Brenda. It's just an example. A good question. 45 degree, this is where we started, right? We know about 45 degree, correct? Sine of 45. So that's easy to compute. Right next to it, I chose 40 degree. It's just a sample. It could be 43, something that's close to 40. Okay, so I chose 40 degree because the formula is all radian. I had to change it to radian. Now you switch to quadratic approximation, you stick it in there. All right, I know it's boring, but can you go ahead and calculate this number with your calculator? 0.7071. If you have a good one, you can just type exactly like that in one line, right? And then squaring and all that. What was that? 0.6427. Right, that's one answer. If I second this one, That could be great. Point 6357. That's different. Very different. Anyone else? Top one. Two more votes. Top one. All right. We'll go by 0.6427. Good? Okay. So sine 40 degrees. It's going to be 0.6427. Isn't that amazing? It's a moment of truth. Now I want you to use a calculator. Actually type in sine of 0.6981 in radian. It should be in radian, right? Then calculator is supposed to give you the similar number, 0.6357, right? No, sorry, 0.6427. Is that similar? Very good. Isn't that amazing? Yeah, if you just throw three f triple prime f, fourth derivative, it becomes more and more accurate. It's just, I don't know, if you're not moved by this one, you're not human. This is just amazing calculation we just went through. Just looking at derivatives, we just found the formula.